Morning. Today I am going to discuss about organoboranes and hydroboration reaction. We know that BH3 is highly unstable. It dimerizes into B2H6. So BH3 is commercially available in the form of B2H6 or BH3 dot diethyl ether or BH3 dot NR3 tertiary amine or BH3 THF. What is hydroboration reaction? Addition of BH3 to C double bond C is called hydroboration reaction. That is RCH double bond CH2, that is an olefin. When it adds to When BH3 group adds to this olefin, it will convert it into RCH2, CH2, BH2. Here BH3 can be written as BH2H. Here B, boron having partial delta positive charge and hydrogen having partial negative charge. So according to Markovnikov's rule, we know that positive charge will goes to the carbon having more number of hydrogen atoms. So we can say that BH2 part, that is positive part, will goes to this carbon and negative part will goes to this carbon. Then we get RCH2, CH2, BH2. Again, this is a borane. When olefin adds to this borane, it will converted into another substituted borane, that is RCH2CH2BH plus will goes to this carbon and hydrogen will goes to this carbon. Then we get RCH2 single bond CH2 twice BH. Again, this is another hydrocarbon. It will reacts with another olefin and get RCH2 CH2 thrice boron. This is a boron compound. So this reaction is known as hydroboration reaction. That is mono substituted, disubstituted hydroboranes and finally converted into tri-substituted or trialkyl borane. Another boranes are disimyl borane. That is when BH3 adds to this olefin. This is a substituted olefin. BH2 part will goes to this carbon and hydrogen part will goes to this carbon. Then we get CH3 twice CH, single bond C, CH3, H and BH2. That will be another borane. Again, if you add an olefin, we get dialkyl borane. That is CH3 twice CH single bond CH CH3 twice BH. This borane is known as dicymail borane and it is a crowded borane. The applications of all the organoboranes will discuss in later. Here we discuss the different types of boranes, organoboranes. This is a simple borane, whereas this borane is a crowded borane. If you sterically crowded, a borane will become more regioselective in its reaction. That we'll discuss in this same video lecture. This is the structure of dicymail borane BH, CH, CH3, C, CH3 twice, CH, CH3, C, CH3 twice. That is the structure of dicymail borane. Then if you add BH3 into completely substituted olefin, we get a borane. That is CH3 twice CH single bond C CH3 twice BH2. And this is again a borane. It is called Texyl borane. Texyl borane is much more crowded than dicymail borane and our normal simple borane. So if you make the borane more crowded, it will have more applications in the regioselectivity of the reactions. And this is another borane called NiN-BBN. That is NiN boro bicyclo 331 nonane. That is NiN-BBN. How can you prepare NiN-BBN? If we add BH3 into this olefin, it will first converted into this borane and there is a chance for intramolecular reaction because it having two alkenes. So this BH2 when then adds to this olefin also and finally we get this structure and this is called NiN-BBN and it have more applications in the reactions of organoboranes, especially in the case of regioselective reactions. This is one of the example. Here when we add BH3 group into this olefin, it will convert it into this product and the important point to notice that BH3 addition is a syn addition. So it will be either upper phase or through lower phase. Here if CH3 group in upper phase, then BH3 addition will be in through the lower phase. If CH3 group in lower phase, then BH3 addition will be through upper phase. That is BH3 addition always through sterically free side and it will be syn addition of BH2 and hydrogen. Here BH2 and hydrogen adds to this double bond through the same side, and it should be sterically free side. Okay. Another example, here also when BH3 adds to this double bond, it will converted into this product. If CH3 is in upper phase, BH2 will be in lower phase. Here the addition of BH2 group will be in this carbon because this carbon having more hydrogen than this carbon. Here this upper phase group is hydrogen, not CH3. Another example is here. This is a compound having three multiple bonds. When adds BH3 group to this compound, there is a possibility of intramolecular hydroboration reaction. Then finally we get a compound like this. Another example is here. When add BH3 group to this type of olefin, here steric hindrance is in this side, so we get a borane that will be in exo product. This is exo product. Whereas if BH3 group adds to this olefin, here steric hindrance present in this area, so the product will be endo product will be the major product. Then another example is here. This is an olefin. Then when adds BH3 to this olefin, we get two products, that is CH3 CHBH2 single bond CH2 C CH3 thrice, and CH3 CH2 CHBH2 C CH3 twice. Here H is, here the double bond is a C, is a substituted olefin with the same number of substitution. Here is the substitution is 1 and here is also the substitution is 1. So BH2 can add either to this carbon or through this carbon. Both product will get, but the percentage of the yield will be different. Which product will be major? That is, when BH2 adds to this carbon will be major product, that is based on the steric hindrance present in this carbon. But the percentage of yield is not much more different. That is, here this compound obtained almost 57 percentage, and whereas this compound obtained almost 43 percentage. The percentage of the yield is much more different. Whereas if you add thexylborane, this is our thexylborane, thexylborane to this olefin, what will be the product? In this previous case, we can get two products. In one case, BH2 adds to this carbon, and another case BH2 add to this carbon. But which will be major product? Of course, this BH2 adds to this carbon will be the major product, and the percentage of yield will be very, very higher in this case. That is 90 percentage we get this product, and only 10 percentage will be this product. So if we use crowded borane like texyl borane or diacetyl borane or 9-BBN, we get more selective products. Here 90 percentage product will be this borane. That is the difference when we use simple borane as well as crowded borane. If we use crowded borane, we can obtain more selective products. Then in the case of alkynes, if you add a catechol borane, what is catechol borane? How can you obtain catechol borane? If you add borane to this catechol, we get catechol borane. This is the structure of catechol borane. Another sterically crowded borane. Here alkynes will undergo hydroboration reaction using catechol borane, and we get a product that will be an alkene, and it will be cis alkene. Alkene having borane, and this is also a borane. Then what are the applications of this organoboranes? Lot of applications for organoboranes, and these organoboranes act as the initial reactant for lot of reactants. First one, organoboranes into alcohols. If you add borane and followed by hydrogen peroxide with a base, this borane will converted into alcohol. That is, one ene will converted into one ol. Alkene will converted into alcohol. What is the mechanism of this conversion? When the alkene adds to the borane, it will converted into trialkyl borane. The mechanism of this hydroboration reaction already discussed. Then in the presence of base, hydrogen peroxide will converted into OH minus that act as a nucleophile. When this nucleophile adds to the boron, and boron is electron deficient, then it will converted into R3 boron OOH, and boron having negative charge. Then when this R group migrates to this oxygen, OH group will getting eliminated. Here this is carbon to oxygen migration, and we get Br2OR. When this procedure occurs repeatedly in the presence of the nucleophile O minus OH, both the R group will migrate, and it will finally converted into BOR thrice. This double arrow indicates the reaction proceeds with the same reaction and same reaction mechanism. And finally we get this compound, and if we hydrolyze this compound, it will convert into alcohol, and it will be 3 moles of alcohol. Consider this example. First step is hydroboration reaction and followed by reaction with hydrogen peroxide and a base sodium hydroxide. The first step we get a borane and followed by reaction with hydrogen peroxide and base, it will converted into alcohol. So the final product is alcohol, and it is similar to anti-Markovnikov addition of water. If we add water into this double bond in the presence of a peroxide, that is called anti-Markovnikov addition or Karash effect. That is already we know the reaction of anti-Markovnikov's rule. What will be the product? The product will be this alcohol. But here this is not following anti-Markovnikov's rule. The reaction follows Markovnikov's rule, but it seems to be the anti-Markovnikov addition of water. Then another example is here. Here the steric hindrance area is this portion. So when we perform this reaction, it will converted into exo alcohol. And here the steric hindrance area is this portion. So when we perform this reaction, it will converted into endo alcohol. Another application of organoboranes is to conversion of tertiary alcohol. Here first step is same hydroboration and followed by reaction with the carbon monoxide, that is carbonylation in the presence of ethylene glycol, and followed by hydrolysis or oxidation using hydrogen peroxide. It will converted into tertiary alcohol, R3COH. That is our tertiary alcohol. What is the mechanism of this reaction? Here organoborane adds with the carbon monoxide, that is C minus triple bond O plus. It acts as a Lewis base. Then negative charge will attach to this boron and converted into R3B minus C triple bond O plus. When this R group will migrate to this carbon, triple bond will shifts to this oxygen, and this is our CC migration reaction, and we get R2B C double bond O R. R group will shifts to this carbon. Then this lone pair of electrons attached to this boron, that is an intramolecular reaction. It will converted into a cyclic product R2B C double bond O plus the lone pair of electrons lost for oxygen. So we get a cyclic product. Then it will undergoes another CC bond migration. This R group will migrate into this carbon and double bond will shift to this oxygen. It will converted into RBCR2 single bond oxygen. Then finally it will undergoes another CC bond migration, and this three-membered ring will breaks and it converted into Cr3b double bond O. Then the last step is hydrolysis or oxidation. It will converted into alcohol, that is tertiary alcohol. For example, if borane adds to this compound, in the presence of hydrogen peroxide and sodium hydroxide, it will converted into primary alcohol and the product will be this. Whereas if we add carbon monoxide, carbonylation in the presence of ethylene glycol, followed by hydrolysis, it will converted into tertiary alcohol. Then this is our 9-BBN followed by reaction with the hydrogen peroxide and base, it will converted into primary alcohol. Another application is organoboranes to halo compounds. When we add organoboranes to halogen in the presence of a base, it will converted into halo compounds, RX. For example, this is our olefin. When borane adds to this olefin, it will converted into exoborane and followed by the addition of bromine in the presence of sodium hydroxide, it will undergoes SN2 reaction and bromine will substituted in the present in the place of BH2 and the configuration will be inverted because the reaction follows SN2 mechanism, so we get inversion of configuration. Whereas if we add instead of bromine sodium hydroxide, bromine and CH2Cl2 dichloromethane DCM, it will converted into this product and the product will be retention of configuration because it follows free radical mechanism in the presence of DCM. Another application is organoboranes to amines. First one is prime conversion into primary amine. In the presence of NH2SO3H, it will converted into primary amine. When this olefin undergoes hydroboration and followed by NH2SO3H addition, it will converted into NH2, that is primary amine, that will be in the retention of configuration. If we add organoboranes into azide R3 R-N3, that is azide, it will converted into secondary amine R-NHR, that is our secondary amine. Then another application is organoboranes converted into hydrocarbon. That is a very important reaction. Organoboranes in the presence of any carboxylic acids and heating, it will converted into hydrocarbon. For example, when alkyne treated with the dicyl borane, it will converted into a borane with the dicyl substituted borane and followed by treated with the acetic acid, it will converted into hydrocarbon RH. So alkyne, in short, alkyne converted into cis alkene in the presence of dicyl borane followed by acetic acid. Another application is conversion of organoboranes into aldehydes. When organoboranes reacts with the carbon monoxide and hydrogen peroxide followed by lithium aluminum hydride reduction, it will converted into aldehyde. Here is the example for the conversion into aldehyde. And another example is for the conversion of organoboranes into ketone. Here, organoborane in the presence of chromic acid, it will convert it into ketone. These are the applications of organoboranes. I hope it's clear. Thank you.